This video carries on from the first video on reciprocal trig ratios. Its main purpose is to introduce these two new Pythagorean identities involving reciprocal trig ratios. There are two of these, and we're going to start with our AS, our core 2 Pythagorean identity, cos squared plus sine squared equals 1. So cos squared theta plus sine squared theta equals 1. Divide throughout by cos squared theta. We get 1 over cos squared theta on the right hand side. Cos squared theta over cos squared theta plus sine squared theta over cos squared theta. But we know that sine over cos is tan, and that 1 over cos is sec. So we can now rewrite this as 1, obviously, cos squared over cos squared, anything over itself. There we have tan squared, and here, of course, we have sec squared. And that's the first of our reciprocal trig identities. Okay, I'd like you to have a go now. Try doing a similar thing and hopefully find an identity linking cosec theta and cot theta. Pause the presentation and have a go. Okay, I hope you gave that a good try. And I hope you were successful. Starting off again from cos squared theta plus sine squared theta equals 1. Dividing throughout this time by sine squared theta, we get 1 over sine squared theta on the right hand side, and then on the left hand side cos squared theta over sine squared theta plus sine squared theta over sine squared theta. So thinking again about what these different ratios are, well, cos over sine we know is cot, and 1 over sine we know is cosec. So this time we get cot squared theta plus 1 equals cosec squared theta. Okay, so to summarise, cos squared theta plus sine squared theta equals 1. We have sec squared theta equals 1 plus tan squared theta, and cosec squared theta equals 1 plus cot squared theta. Notice they're all identities, they're all true for any value of theta. An important point to generally avoid, very, very rarely you may get a question where you'll see a square root of something like this, but on the whole, never try and square root these identities. There's two main ways we use these identities: to solve quadratic trig equations and to prove other identities. Very similar to what we've already done with sine squared theta plus cos squared theta equals 1. Okay, first example then. 2 cosec squared theta equals cot theta plus 12. Now remember the method we use to solve these sort of problems. We're driven by the linear term because that's the term we're going to struggle to change. Remember when we were dealing with sine squared theta plus cos squared theta, it would be the squared term we would try and change. Do we have an identity that links cosec squared and cot squared maybe? We do. That second one we managed to derive earlier, cosec squared theta equals 1 plus cot squared theta. We want to replace the cosec squared, so it's straightforward really. We just sub in. Don't forget your brackets. Remember, any time you sub in, use brackets. Even if you don't need them, it's good practice. We're subbing the whole of that in, so use brackets. Okay, if we multiply out the brackets and tidy it up, we end up with 2 plus 2 cot squared theta on this side. Take the minus 12 over, gives us minus 10. Take minus cot theta over. We end up with 2 cot squared theta minus cot theta minus 10 equals 0. And that will factorise like that. That gives us two solutions. Cot theta equals 5 over 2 or cot theta equals minus 2. We don't have these reciprocal ratios on the calculator, so we flip them, we turn them into tan theta, remembering that tan theta is 1 over cot theta. So we flip the fractions and we get 5 over 2 minus 2 over 1 going to 2 over 5 for the tan and minus a half. To solve, it's easy with tan, isn't it? We find our principal values and we add 180 or subtract 180, whichever is appropriate to find the values within our interval. And there we go. So we can see there we've got these values here. Okay, now it's your turn. Have a go at these two. If you're successful or very close, obviously, as usual, that means you're ready for the lesson. Otherwise, spend a bit more time going through the video, have a look at this at My Maths or in the textbook or whatever way you prefer to make sure that you've learnt it and you've applied it before the lesson. So pause the presentation, have a go. Okay, let's go through the answers then. First one, tan squared and sec. And again, it's fairly straightforward because we're there already, aren't we? We have an identity linking sec squared and tan squared. It's the tan squared we're trying to replace, so we are going to need to rearrange this a bit so we can make a substitution for tan squared. We need to make tan squared x the subject, get it alone on one side, so we simply need to subtract 1 from both sides. So there's our substitution for tan squared x. Again, make sure you bracket it when you substitute it, tidy up, and we end up with this quadratic. It does factorise, but of course you can always use your calculator. And we get sec x as 3 over 2 and 2. Remembering that we haven't got sec on the calculator, so we need to flip the fractions for cos. And they're both valid cosines, so we can find solutions for both of them. We're looking at all the solutions between 0 and 360, so each of these values will give us two solutions. If we look at the graph, that will remind us where we can find the solutions. We can see here in the calculator we get the two principal values. For 2 over 3, 2/3, we get 48 degrees. For a half, we get 60 degrees. And then looking at the graph, for 2/3, there's our 48 degrees. Remember, with cosine, it's 360 minus our principal value. So the second value is 312 degrees. Do the same for 60 degrees with a half. And we get 60 and 300. And there's the four answers. Second one then, cot squared and cosec. Again, it's fairly straightforward because we've got that identity there, which links cot and cosec. This time it's cot squared we need to replace, so again we need to do a bit of rearranging. And remember to bracket what we sub in, multiply out the bracket, tidy it up, factorise it or use equation solver or G-solve on the calculator, whatever you're more comfortable with. This time we get 1/4 and minus 2 as our cosec answers. Cosec's 1 over sine, so we flip the fractions to get the sine values. This time, what do you notice? Well, hopefully you spotted that there's no solutions for sine x equals 4. You should know that sine x only has values between -1 and 1. So we can ignore that one. Always write down no solutions and then solve for the other value, which is -1/2. The first value we get, note that we're in radians, note that we're between -pi and pi. So our first value is -pi/6. That would be the principal value. We'll look at the graph. There's -1/2. And you can see that we've got that value there. And you should be able to tell by symmetry what this value here is going to be, bearing in mind that obviously that distance there is the same as that distance there. So if that's -pi/6, then I would hope you'd be able to work out that's -5pi/6. And those are the only two solutions. Okay, well, as I said, if you did reasonably well at that, you're ready for the lesson. If not, go back over it, look through my maths, use the textbook, or if you need to, come to support and ask.